So before we do this one, let's sort of summarize what we've done so far. So as far as a summary of the things, we always started with our horizontal asymptotes or holes. And we do that by making sure we start by factoring. Once you've got your horizontal asymptotes and holes and you've factored, you then look at your, sorry, those are vertical asymptotes. Vertical asymptotes and holes were first. And then we look at our horizontal asymptotes and oblique asymptotes. You find your horizontal asymptotes and oblique asymptotes by looking at the highest degree. Right? If it's group 1 where the highest degree is on the top, then it might be a hole or it might be an oblique asymptote. If it was group 2 where the same degree on top and bottom, then you're going to get a horizontal asymptote. And group 3 where the biggest power was on the bottom, then you're going to get an asymptote at y equals 0. Put in your x-intercepts and y-intercepts, if there are any, and then any other point as needed. Sometimes your x-intercepts and y-intercepts are enough points to draw the whole graph. Sometimes they're not. We noticed in example 2 we didn't do the x-intercept and we got our graph wrong at first. So it's important that we do all of our x-intercepts and y-intercepts, because if you do your x-intercepts, that's when you're going to find out whether your graph passes through that asymptote. Okay, so there's the idea. We'll start with factoring completely to see if it has vertical asymptotes or holes. So this first one, top is x minus 4. Can you factor the bottom? Difference of squares, x plus 2, x minus 2. So with that in mind, nothing cancels out. We'll start our graph. We have 2 asymptotes. One asymptote at minus 2 and the other asymptote at 2. So we've done step 1, all vertical asymptotes and or holes. This one just has vertical asymptotes. Step 2, we're going to look at, so now what's the highest power? The highest power is an x squared. We have 1 x squared on the, so what does that mean? Y equals 0 is another asymptote. Well, this is going to be another interesting one that crosses the asymptote. All right. So now as far as our graph goes, let's label all of our x-intercepts and y-intercepts. Can you see when the whole thing is 0 that you're going to have 1 as a y-intercept? And when is the top equal to 0? At 4. So there we have a couple of points. Is it enough to draw things? Not really. Because here we can assume, yes, it's going to be going towards the asymptote. we know that there's no more x-intercepts. The only x-intercept is at 4. So this middle section, I know is going to do that. Because if it went down, it would have to cross the x-axis, and I know there's only one x-intercept. Can you see I have a little bit of a problem here to the right with that x equals 4? I don't know if it's going to be going up towards that asymptote or down towards that asymptote. But I can get some information if I plugged in 3. If I plug in 3, can you see that I'm going to get negative 1 on top and 5 on the bottom, which is negative 1/5. So if I plug in 3, I get negative 1/5. That's telling me that it's going down like this. This graph is going to do something weird and come back towards that asymptote as x gets very, very big. I don't know how high that bump is going to be, but I know that it's got to cross, and then eventually it's going to come back down towards my asymptote, because that's what horizontal asymptotes do. They tell us what's going to happen later on. The good news is that from what I've talked to people on the provincial committee, they're not going to give you ugly graphs that do funny things like these ones. They're going to be the pretty typical graphs that follow asymptotes easily. So that's a good sign. Okay, but we're still going to practice these ones and see where they go. I wouldn't put one like this on your test either, because you feel like, ugh, what's happening here? And finally, in the other section, we need a point less than negative 2. So if I plug in negative 3, can you see that I would get negative 7 on the top? And if I plug in negative 3, I'm going to get 5 on the bottom. Negative 7/5. So here, if I plug in negative 3, I get negative 7 over 5. And it's going to look something like this. It may do additional weird things that we can't see here. Sometimes the graph does weird things. This is our best guess, and this is for what we have until you take calculus next year and learn additional skills to improve your graphing. This is all that's expected right now. Get this basic idea that you can plot some points to figure out some other things, that you can find all the asymptotes and get a basic sense of what might be happening. Second one. First of all, we factor completely. X plus 2. X minus 2, x plus 3, x minus 3. And we start with our horizontal asymptotes. Can you see that there will be 1 at minus 3? And 1 at 3. Step 2. Let's look for other asymptotes. Highest power, x squared on the top. We have an x squared on the bottom. That simplifies to y equals 1. X-intercepts, we're going to get an x-intercept at minus 2 and an x-intercept at 2. We can see that by how it's factored on top. If we put in 0 for x, can you see you would get negative 4 over negative 9, which would be 0,4 Those points have to be connected, and we got those asymptotes, so we have the middle section. We still need a point to the right of x equals 3, and we still need a point to the left of x equals minus 3. So plug in 4. Can you see on the top you would get 16 minus 4, 12. And plug in 4 on the bottom, you would get 7. 12 over 7 is 1 and a bit. Okay, going to estimate where that is. It's above the asymptote. So when I plugged in 4, I got 12 over 7. And when I plug in negative 4, because it's squared, it'll come out to exactly the same thing. So the ones you can practice for this one are 9 and 10.